Hello everyone, my name is David Golchinfar. I'm research assistant and PhD student at the University of Applied Science, Bonn-Rhein-Sieg, and today I'm gonna present you our paper Exploring Future Work, Co-Designing a Human-Robot Collaboration Environment for Service Domains. Beginning with the motivation, there's an increasing interest in AI and service robots in service domains like retail or healthcare. But user experience with autonomous systems and service domains remain disappointing due to complexity and unpredictability of service processes. Therefore, human supervision and maintenance is necessary but requires a specific skill set. And herein lies the challenge. Service robots need to anticipate and comprehend needs and requirements of the customers. Such skill sets can be found rather in trained service operators. Service operators need to be empowered to teach and train service robots with their skill set. And therefore, an environment for human-robot collaboration is required to explore the design of future work involving humans and robots in the service domain. Our related work based on three underlying concepts for human-robot collaboration. The first one is the end-user development, where tailored applications become easier for end users when the gap between design and use is bridged. The second one is the use of Wizard of Oz technique, which has a long tradition with regard to natural language processing, emotion and non-verbal behavior, and also robot navigation. And the third one is the teleoperation and exceptional takeover control. So we're bringing humans back into the loop, and the human may recognize exceptional situations of the robot and derive solutions. Our research question was, how can service operators make early first-time experience with service robots in their daily business routines to express their needs with respect to design of future work scenarios? Our study setting was built in a long-term project with a pharmacy in Germany, started in March 2019. We had a 5-month sub-study exploring the opportunities of service robots in a pharmacy context and co-design a human-robot collaboration environment. The pharmacy is located in a shopping mall, heavily frequented by customers. 13 service operators work at the pharmacy. Our service robot Pepper, a humanoid robot, has been applied at the pharmacy for 4 to 5 hours once a week. We had 3 research stages. The first one was learn about relevant use cases and routines of the pharmacy daily business. The second, to develop an interface that allows human-robot collaboration in relevant use cases and evaluate the interface with respect to usability and user experience. Our research design includes data collection and data analysis. The data collection includes workshops, interviews, and observations. We had an ideation workshop with all service operators to introduce the robot and learn about frequent important use cases of the pharmacy. And we had an evaluation workshop, conduct 3 evaluation scenarios to assess human-robot collaboration through the designed interface. And the evaluation scenarios were based on daily business routines. Also, we investigate how service operators may teach new skills to the robot to improve its autonomy. The data analysis consists of a thematic analysis approach, including text and video materials. Our technical infrastructure is split in 3 sections. The first section represents the core interaction between the customer and the service robot. The second section provides the front end for the remote operator to control and train the robot. And the third section presents the backend structure where the robot pre-processes all incoming signals and communicates with our cloud services. Our HuRoCo interface prototype consists of 4 modules. The first screen shows the text-to-speech interface. The second screen depicts the interface that allows the remote operator to control motion and animation of the robot. The third screen shows a chat log that documents a complete communication history between the service robot and the customer. Finally, the fourth screen shows the training interface. The key findings of the ideation workshop shows that from the service operator perspective, the most important use case were product and service advice, product location, and provide information. The service operators believed that it would be beneficial if the robot could support them in the use cases, as the use cases are quite standardized but require many resources to be completed. The key findings of the evaluation workshop shows that all participants were able to complete this scenario step 1 and 2 of all use cases. 4 of 5 participants were able to complete scenario step 3. Participant 3 failed due to technical issues with the dialogue engines, but all participants understood how to use the HuRoCo environment to control and train the robot. Also, the prototype was easy to use and easy to learn. But also the evaluation workshop shows remaining problems, for example, the robot control, interaction, latency, and robot training. So the text-to-speech was a problem for the service operators because of typing speed of the service operators. It's a problem for real-world customer interactions, and the delay between user input and robot output was perceived as too high. And the participants were reluctant at first and needed some time to get familiar with the training process. But all participants were positive and open-minded and saw possibilities in new flexible work forms and work time models. But however, they insisted that real social context with customers have to remain relevant. Also, our study confirms previous findings in participatory design, so first-hand experience empowers users to envision future forms of work better. So it's important for creating places for co-design that less emphasize on high-tech solutions, more emphasize on trust and long-term collaboration, and promote early first-time experience to empower service operators to engage in design of future work. The proposed interface enables service operators to use service robots for their daily business tasks. Social aspects of human-robot collaborations need to be carefully considered. Such future work forms may provide benefits, for instance, to work-life balance and health. So there's increasing introduction of service robots into service domains, but current work arrangements and conditions may change considerably. And understanding how future work forms may affect employees and how they can engage in the design is key. Thus, interface and environments that allow first-time experience of service robots are required. Also, societal challenges need to be considered and investigated carefully. For example, social connectedness and ghost worker debate. Thank you for your attention.